So the section 7 in the packet. I guess the first thing I'll start with is that we're only doing part of it. And I say only part of it because you've already done the first half of it. We're only doing that portion of it. So the infinite limits, we've already done. The infinite limits first half of this section is talking about vertical asymptotes and holes. And we definitely did that. I covered it quite a bit the last couple sections, where if you have a vertical asymptote, your graph basically has to go up or has to go down. And so those are called infinite limits because your answer is infinity or negative infinity. So that's why they're called infinite limits. The second half, limits at infinity, which obviously they sound ridiculously similar. Limits at infinity is trying to find the limit as x approaches infinity. So the first one means the answer is infinity. The second one means you're using infinity in place of x. So I'll just super fast review the infinite limits, the part we're skipping. So vertical asymptotes look like this. This is a good example of the fact that your graph has to go straight up or straight down. And then the way that we found which one it was, let's say, what's that one at, 4? Yeah. So let's say this one has a vertical asymptote at x equals 4. That means there was a factor of x minus 4 in the denominator that didn't cancel. And the limit at 4 to the left and 4 to the right is what we would want to know. So if you're doing the limit 4 from the left, then you would essentially plug 3.9 or something like that into the equation and find out if your answer is positive or negative. If your answer is positive, that means it's positive infinity. If you plug 3.9 in and get a negative answer, then that means your answer is negative infinity. So this is what we did for the last couple sections. We didn't have to do it a lot, but that's what we did do. And same with 4 to the right, you would plug in 4.1. All you're trying to do is figure out if the answer is positive infinity or negative infinity. Yep. Oh, wanted to go back. Where was it? Oh, right here. This you should know pretty well by now. If a factor cancels, that's a hole. If a factor remains in the denominator, that's the vertical asymptotes. My guess is you should be pretty proficient with that by this point. It's technically part of this section, but we've been doing it all along. And then this gets to this. So limits at infinity is essentially end behavior. In Algebra 2, you guys did end behavior, and it was only of polynomials. And you would have had even polynomials went up and up, all odd polynomials were down and up. And a negative on the front would flip them, you know. In pre-calc, although I definitely heard you guys kind of glazed past this because this might have been during the full distance learning part. It didn't sound like you guys did horizontal asymptotes much at all. Okay, well, that was supposed to be in pre-calc. In pre-calc, you're supposed to do end behavior on rational expressions, and instead of calling it end behavior, they call it horizontal asymptotes. And there's some rules you generally use to figure out if the answer is going to be 0, a number, or infinity. But apparently, it was kind of universal that nobody really remembered it. So that's why I'm guessing it might have been one of the topics that was cut. I don't know. That's fine though. Even if you knew it, it wouldn't necessarily help you or hurt you in this. So calc, we basically get to the point where we can figure out end behavior, which we now just call limits at infinity, for any type of equation. It doesn't have to be a polynomial or rational. It can be whatever. So let's kind of talk about, we'll work our way up here. So I believe it was exponential where we were using infinity. Is that right? Okay. So if you get 1 over infinity, it's hard to say that over and over. 1 over infinity. Yeah, we'll just call it finity. So much easier to say. I feel like we're making that slang. Kind of like that one better. 1 over infinity. What answer would that be? 0. And that's that's because the number on the bottom is so much bigger that it's so close to 0, they just call it 0. Okay? Where should I go from here? So we also had a few like this, where if you were putting infinity in place of x, we basically talked about how the 5 was pretty unimportant because infinity is such a big number that if you subtract 5, there's virtually no difference. Okay? And so we essentially did that. Now we're going to use this same idea where if we have, those are good lines, if we have something like this, if I'm putting infinity in place of x, like it may not seem like it, but these are so much smaller than infinity squared that they're worthless. Not worthless. They don't change the answer. Yeah, we don't want to be mean to them. They're not worthless. Right. Yeah. And so here, let me undo these lines for a second. So here's the part that mentally most people would not have thought of at this point. Like you guys are so used to doing squared stuff that you don't really even think about what it stands for. Like, I bet person for person in here, if I asked you to explain what 4 squared means, you would say 4 times 4, right? And it's not wrong. 4 squared means 4 fours. Like, that's the whole point of what multiplication is. It means that you add it a certain number of times. So 4 fours being added would be the 16. That's squared. So infinity squared means an infinite number of infinities. So like that's a lot, you know, right? 3 infinities is an awful lot smaller than an infinite number of infinities. So anything that is a lesser degree is going to become unimportant. So when we're working with any of our problems, when you plug in infinity, you basically only focus on the highest degree term. Every other term you pretty much completely ignore. And it seems weird to do, but that's what you do. Okay, so let's do an actual problem. Now I gotta think of these off the top of my head. That's worse. Okay, so say we're doing the limit as x approaches infinity of this one. First thing we do, we cross off anything that's, because we're plugging in infinity, I'm going to ignore terms that are lower than the highest degree. I'm having trouble speaking today. So I'm going to cross off plus 3. I'm going to cross off minus 6x plus 9. So numerator and denominator, I'm not going to cross off 4x because it's the highest degree in the numerator. Like the whole point of a fraction means that we're comparing two parts. Yeah, I'll save the rest of this so that you can check it out. So I'm going to focus on 4x over x squared. And then I'm going to plug infinity in. So I've got 4 infinity over infinity squared. Now that we have it simplified down, we generally can treat it like a variable, where these are infinities. So 4 infinities on the top compared to an infinite number of infinities on the bottom. These are treated as if they're kind of equal things. And so this reduces down to 4 over infinity, which we would make the answer of 0. Now, if you remembered the pre-calc version, you would be able to answer this without plugging in infinity, because you would have known that it would have been 0. But that's okay. I mean, like, plugging in infinity, this method isn't really difficult. And this 100% is not like official, real anything. This is just, you're able to figure out the answer in your head most of the time, or with very little work. Let's do negative 3x. Get adventurous. I don't know, who should we go with? I feel like I remembered somebody got picked on a lot on Tuesday. Was that a Purva? That was Riley? Do you want to call on somebody?
Yes.
I'll let you choose. I don't remember who chose you, so.
Oh.
I can't hear very good. Oh, Cassie? Okay. Cassie, so the first thing I want to do is, because I'm plugging in infinity information, I want to take out lower degreed things. What would I cross off on this one? So on the, let's, yes. So on the top, we've got two terms. We've got 5x and we've got 2. Those are the two terms on the top, the 5x and the 2. The 2 doesn't even have a variable, so then that's considered lower degree. So that's why we cross it off. On the bottom, same thing. If we had something that had a squared, that's a higher degree. Cube would be higher degree. So you kind of go by the highest power. Question? We're going to. What do you mean simplifying? Okay, you can ask it later if you want then. How's that? So all I was doing for right now was I was just trying to figure out what isn't going to affect the answer. So then I have 5x over negative 3x, plug in infinities, and I can treat them as variables at this stage because there's no other numbers and info. And these actually cross out. And so my answer is negative 5/3. So if I would have graphed this answer, I would have found a horizontal asymptote at negative 5/3. Is this feeling okay so far?
Yeah.
Okay. I mean, like, I didn't want to throw weird ones at you yet until it felt comfortable. Yeah. I don't know. I'm making these problems up. Is that what you're asking?
Yeah.
I'm just totally making these up off the top of my head.
We're not supposed to be filling in the notes.
No. Well, I mean, you can write notes. You don't like. It's not like you can't write anything down that's not written in
No,
there.
I'm just asking if they're like in the notes.
No, they're not. We haven't. We're going to get to those. I wanted to do this first.
If there wasn't like a horizontal asymptote, would then it be like bigger than
My ears are super plugged, so I can't hear anything.
If there wasn't like a horizontal asymptote, would your final answer just be like infinity or negative infinity then?
Yes. Yep. That's like this one. So if it has a slant asymptote.
So like, I remember in pre-calc, or maybe it was algebra 2 learning how like if the numerator has a greater degree than the denominator, and then there's like no horizontal asymptote, and there are a bunch of other rules. Is this just like a different way of doing that?
Calc is how we came up with those rules. Those rules were created from doing limits at infinity.
And so if we're only solving it to like infinity, what about if it's negative infinity?
Oh, I actually tried writing that here, but I was talking when I was writing. Yes, we're trying to do all versions of everything.
So will we then have to find like negative infinity of the same equations to know there's actually that asymptote? Or are we saying like from the right side and then either in front of the
So what you're asking me about is to prove a horizontal asymptote, you have to find the limit at infinity and negative infinity,
Yeah.
but these are slightly different. So what we're doing right now is just finding limits of infinity or negative infinity, but we're not necessarily like trying to verify a horizontal asymptote. Yeah, if we're not at that kind of detail yet. You're right though. Just these are super hard to come up with on. Actually, you know what? I'm just going to stop making them up. So here. So example 4 in our notes is where the examples start. I wanted to try to explain them first so that they sort of made sense what we're doing. Okay, now for A. Theoretically, the same rules still apply. It doesn't have to be a rational expression, where we're just going to focus on the highest degree. Where this minus 4 isn't really going to change that answer when I plug in infinity. This plus 3 isn't really going to change that answer. So my focus is going to be infinity squared times infinity squared. Were you asking me something? Okay. I'm half deaf right now because my ears are just super plugged. So infinity squared times infinity squared is going to be infinity to the 4th, which isn't like an actual real answer. It's just infinity. Yeah, so when we're doing a rational expression, we keep the powers on them because we're just trying to compare numerators and denominators. But if we don't have anything to compare, well, then it won't matter. Okay, B. Cassie, who are you going to call now?
Oh, Ryan.
No. The whole point of that was that she got called on a bunch of times on Tuesday. So, okay, some variety on who's being chosen would be really nice. I was going to do the roller, but my ears hurt, so I didn't want to hear the balls rolling over and over.
No.
Okay. Addison, thoughts on what we should do to start?
Um,
How did we start the other ones?
you can take out the 4 because it's the, yeah, good luck too, because you're looking at the highest.
I can also take out the minus 2x.
Yeah, and the minus 2x, because you're looking at the highest one.
Yep.
So did you get 5 to the negative infinity cube? The 5 wouldn't really matter because it's not really big. And the negative infinity cube would mean that it's still negative infinity, so the answer's crazy.
Perfect. So you're right. You can leave the 5 in there for now if you want, but all that's going to happen is you're going to take 5 times negative infinity. The negative infinity cubed was kind of the focus of this part. And if the 5 affected anything, you could leave it until the end, but it doesn't affect this one at all. So it's just negative 5 infinity isn't like an answer.
If it was infinity, negative infinity squared, would it be just positive infinity?
Correct. Correct. The power affects what's being plugged in. Oh, I thought you had another question. Okay, now do we need to do C and D? Should we do those quickly? Okay, yes, we can do that. You get to choose who's going, but no paybacks.
That is payback, but I'll accept it.
Not necessarily, you didn't call on me today.
Wow, you remembered that from like weeks ago?
Yeah, she did.
Wow. All right. All right, Audrey. Guide me.
Take out the negative
Good? And I'll emphasize again, we only do this when we're plugging in infinities. And that's just because infinity is not a regular number. Okay?
And then the two infinity squared cancel each other out.
Good?
The answer's 3.
Perfect. So this method I like because a lot of these answers you can pretty much just see in your head right away if you know the steps without writing anything down. Now, obviously, if you want to write down work like I did, took a half a second there. But these are really good methods for multiple choice questions. Okay, D. I suppose I should have waited until somebody told me to do that, but who's going to be the person that's going to guide me on D? Okay.
That's easy.
I started you.
You already started.
Yeah.
And then the x squared and x will cancel out in the fact that there is still the
Reduce,
infinity on the
yep.
bottom. So it'd be 5 over infinity, which
5 over negative infinity.
negative infinity, which is pretty much just 0.
Okay. If the negative symbol, if it was negative infinity over 5, then the answer would be negative infinity, like the negative would affect it at that point. But on this one, since your answer is 0, we're not going to answer negative 0. So good. Nice. Okay, let's go to a harder one. What I'll call the hardest. Wait, did I screw up? Did I skip it? Well, this isn't going to be ridiculous. Where'd it go? Here we go. Number 8. Example 8. Basically, if you can do example 8, then you can do any question with the infinities. Question?
I need to know like the stuff on page 16.
I don't know what's on those pages.
It's like,
Is that right before this page?
yeah, it's just asymptotes. It's just calculus knowledge for asymptotes.
You don't have to. If you want, you can.
What will it be on the test?
No. Well, I mean, like, not directly. Like, you can know, you should already technically know them is kind of the thing. But if you don't, it won't hurt you. Okay, my guess is you are either done or you're stuck. Now, where you've been slightly misguided in the past, the square root of x squared isn't x. Because every class up to this point, you were kind of purposely given information where you wouldn't have had to worry about the answer. The square root of x squared is technically absolute value of x. And that's because no matter what number you put in place of x, including negative numbers, if you square them, they become positive, and then the square root of that positive one stays positive. So it's technically the absolute value of x. You've just never really needed to run into these details before. So if I simplify this, because I think most of you probably right away crossed off minus 3 plus 4. And I was going to guess that some of you guys simplified it to regular x. And I would totally understand why you would do that. Honestly, if you left it square root of x squared, it probably would have been easier too. And it's not going to matter for infinity, because when you plug in infinity, you'd have 3 times infinity on the top, absolute value of infinity on the bottom, which is infinity. And so these cancel out and you're left with 3. And that's what you can kind of see on the picture. The limit as x goes to positive infinity, which means the right-hand side, it's up at 3. When you plug in negative infinity, on the denominator, that turns to positive, and so you have negative 3 infinity divided by infinity, which is negative 3. And you can kind of see that in the picture as well. This is probably about as tricky as you'll run into, but it's actually pretty common on the AP test to get a limit question like this. And so I like teaching this method, because this method kind of allows you to not worry about the extra information, which can be confusing depending on the method you're using. The real method, it's not like it's horrible, but it's definitely really slow compared to this, and I just don't find it worth it. Like, it just takes you away from the goal. Do you guys want me to go over any parts of this? How did it go? Okay. So then we have about 15 minutes left. Here's what I'd like you to kind of do. My guess is if you do the infinity questions, the limit at infinity questions, first in the homework, you'll be done with those before you leave. And then over the weekend, if you can do like half of the rest of the homework, that would be great. I'll answer questions on Monday in class, or I'll give you a little bit of time to work in class as well. So you don't have to have this section's homework done by Monday, depending on what you have planned for the weekend, whatever. If you want to finish it over the weekend, go for it, but you don't need to. So I would work on the infinity ones here in class.